ओके मेरी आवाज आ रही है? Okay, let me share the screen. Here is our whiteboard. चलो आ गया. So हमने last time किया था theorem. What was that? It was. Let me join करते हैं. हाँ, तो हमने किया था if जो हमने किया था theorem, that was if R belongs to this subscript Rn and Z belongs to T, by that I mean mod of Z is equal to 1, then this was true. That is R dash Z, let me call it R star Z का derivative ऐसे in modulus plus R dash Z is less than equal to modulus of B dash Z into norm of R. तो ये हमने basically prove किया था. And of course, you know what is RZ. R of Z is a function of the type P of Z divided by W of Z, right? And W of Z is prescribed, yani it is given that this is equal to summation J runs from 1 to N, Z minus AJ with these AJs lying outside the unit disk. And of course, then accordingly, our R star was defined as, I think, P of Z into R of 1 by Z bar of whole bar. So if we use those definitions, we prove this. Okay, now इसकी corollary जो कि straightforward है, कुछ खास करना नहीं है इसमें. Corollary: if R, same thing, Rn is self-inversive, then R dash Z in modulus is less than equal to 1 by 2 modulus of B dash Z into norm of R. Now, you know, norm of R is basically, it is supremum over mod Z equal to 1 of modulus of R of Z. So proof of the corollary, that's straightforward. Now if R is self-inversive, it implies that R star Z is the same as lambda of R of Z for some lambda, for some unit modulus lambda. Therefore, from above theorem, अगर मैं above theorem और apply करूं, तो मुझे मिलेगा from above theorem R star Z की जगह आएगा lambda into R of Z. So you would get from above theorem, अगर उसमें मैं ये definition substitute कर लूं, मुझे इसका derivative ढूंढना है. So it would be lambda times R dash Z plus R dash Z is less than equal to modulus of B dash Z into norm of R. हाँ, यहाँ मैं लिख क्या बोलना, for mod Z equal to 1. This is also true for mod Z equal to 1. या जैसा कि हम लिखते हैं, हाँ वो तो है ही, Z belongs to T. Okay. So of course इसका मतलब हुआ कि twice modulus of R dash Z. This is for Z belonging to T. Okay, it's less than equal to B dash Z into norm of R, and we are done. Of course, तो मिल गया ना हमें 2 को इधर लाया, so it means that R dash Z is less than equal to 1 by 2 times B dash Z for a self-inversive rational function. This must be true for mod Z belonging to T. Okay, so ये था corollary, which was straightforward. Now we move to another theorem. Theorem ये है, suppose same thing, जो हमारी notation है, R belongs to our script Rn rational function with prescribed poles, and by our choice, n poles lying outside the unit disk. And suppose all zeros of R lie in T union D plus. By this I mean basically in the region, that is in the region outside the unit disk, yani region mod z bigger than equal to 1. तो इसके zeros अगर बाहर है, poles तो है ही बाहर, लेकिन यहाँ हम कर रहे हैं zero boundary पे भी अगर हो, तो boundary and outside of the unit disk, then for z belonging to T, that means z having modulus 1, we have R dash z is less than equal to 1 by 2 into B dash z into norm of R. मतलब it is the same thing as corollary 1, लेकिन वहां पे हमने assume किया था R is self inversive, तो यहाँ पे हम R को self inversive नहीं मान रहे हैं, बल्कि सिर्फ ये मान रहे हैं R के जो zeros हैं they lie outside or on the boundary of the unit disk. मतलब इससे पहले जो हमने किया था वो exactly ही था ना, if you look at this thing, it is the same conclusion, but यहाँ पे R is self inversive and we are silent whether the zeros are outside or inside. And remember, zeros of R are the same as zeros of P, because R would vanish if and only if P would vanish. So what we are saying is जो pz ऊपर है numerator, the polynomial, इसके zeros अगर बाहर हैं या on the boundary है, then you would have again have this type of inequality, whether the polynomial is self-inversive or not. Okay, whether the rational function is inversive or not, self-inversive. Okay, and the equality holds. Equality holds for Rz equal to, for Rz equal to some alpha times B of z, which is the Paschke product, plus beta with modulus of alpha is equal to modulus of beta is equal to 1. So that's the theorem. And as usual, for the proof of this theorem, we need a couple of lemmas. Now, for the proof of this theorem, we need the following lemmas. पहला वाला straightforward. Lemma 1. Lemma 1 है, suppose z belongs to complex domain, and z is a complex number, then it's straightforward to see that real part of z is less than equal to 1 by 2 if and only if modulus of z is less than equal to modulus of z minus 1. I think हमने ये किया है. And real part of z is strictly less than 1 by 2 if and only if modulus of z is strictly less than modulus of z minus 1. मतलब इसमें कुछ खास करना नहीं है. So suppose ये वाला मैं लूँ, कोई भी लूँ, ये अगर लें पहला वाला, so the real, it implies that twice real part of z is less than equal to 1, which would mean that, what does it mean? It would mean that 0 is less than equal to 1 minus twice real part of z, which would imply that both sides, if and only if and only if, it means that modulus of z square is less than equal to 1 minus twice real part of z plus modulus of z square, and of course, which is the same thing as modulus of z is less than equal to modulus of 1 minus z plus square, which is the same thing as modulus of z is less than equal to mod of z minus 1. Well, you can check that, because this is actually 1 minus, what will be this? Twice real part of z should be the z plus z bar, I think. plus z into z bar. As you can see, अब थोड़ा खुद ही कॉमन वॉमन निकाल लो z bar को तो ये मिल जाए. Okay, so this is straightforward. Now let's come to lemma 2. lemma 2 थोड़ा लंबा है और important है. पहला वाला तो straightforward है. lemma 2. Now again we have, suppose R is a rational function with prescribed poles outside the unit disk. That means R belongs to Rn. तो पहली बात इसमें दो statements है. If all the zeros of R lie in T union D plus, जो ना हमारी ऊपर condition है, that means in the region that is more in mod z greater than equal to 1. So then real part of z into R dash z divided by R of z is less than equal to 1 by 2 modulus of b dash z for z belonging to T, and of course rz not equal to 0. Second part जो है statement का वो ये है, if R has exactly n poles, जो कि हमारा है exactly n poles a1 a2 up to an, and all zeros lie outside, all zeros lie inside. Actually ये लेमा हमें थोड़ा बाद में चाहिए, but in ये जो दूसरी स्टेटमेंट है लेकिन इकट्ठे प्रूव होते हैं तो let's keep it that way. That is in the region mod z less than equal to 1. ये t है वो अपना bold t of the unit disk and the inside d minus का मतलब inside of the disk. Then ये थोड़ा लंबा चौड़ा है. The real part of same thing, z into r dash z divided by r of z is greater than equal to 1 by 2 modulus of b dash z minus 1 by 2 into n minus m for z again belonging to t and r of z not equal to 0. Of course, where m denotes the number of zeros, right? जरा मैं लिख देता हूँ दूसरे पेज पे. Where m denotes the number of zeros, number of zeros of rz, of course, counting multiplicities. Counting multiplicities. मैं वापस जाऊंगा उस पर क्या बता रहे हैं. तो of course इसका upper bound ये होगा, लेकिन अगर zeros inside है then this will be greater than equal to this quantity. मतलब this thing minus some quantity, right? Which of course brings into consideration the difference between the poles and the zeros. Okay, so let's prove it. जब हम इसको प्रूव करेंगे तो ज़्यादा साफ हो जाएगा मसला. Let's prove first. Proof. दोनों को इकट्ठे ही करेंगे क्योंकि स्टार्ट में हमें एक ही चीज करनी है. Now let rz be equal to, of course it should be of the type pz divided by wz. Now this belongs to my rn, and let d1 d2 up to dm be the zeros of pz, which is the same thing as zeros of rz, right? So pz vanish karega तो rz vanish karega. Then m is less than equal to n, क्योंकि ये जो है it is at most a polynomial of degree n. इसकी ज्यादा से ज्यादा n 0 हो सकते हैं और it is exactly इसकी डिग्री n है ही. वो to remind you wz is equal to product z minus aj, j runs from 1 to n. So m has to be less than equal to n. And if I want to find the derivative, as usual, r dash z किसके बराबर होगा? It would be wz into p dash z minus pz into w dash z divided by, of course, wz का स्क्वायर. वो किसके बराबर हो गया? That would be wz khatam. So let me write it as p dash z by wz minus p of z into w dash z whole divided by wz square, right? And if I multiply both sides, यानी r dash z by r of z बराबर होगा p dash z divided by wz minus bz w dash z divided by wz का square whole multiplied by 1 by r of z. 1 by r of z का multiplying by wz divided by p of z जो बराबर होगा, if you see that पहले करेंगे तो wz खत्म, so it will be p dash z by p of z, right, minus of course wz खत्म, p dash will be minus w dash z by wz. Now we know something. What do we know? Both pz and wz are polynomials और इसके zeros जो हैं वो है b1, b2, bm और इसके जो zeros हैं वो है a1, a2, an जो ना poles हैं rz के, वो एक्चुअली zeros हैं wz के. और हमें पता है अगर तुम्हारे पास इस तरह का एक्सप्रेशन हो फॉर टू पॉलिनोमियल्स, हम ये 50 बार कर चुके हैं, मतलब दिस थिंग इज इक्वल टू समेशन k runs from 1 to m 1 by z minus bk क्योंकि इसके zeros हैं up to m minus summation k runs from 1 to n 1 by z minus bk. Now that's just standard way of writing it. So which implies that z into r dash z by r of z, ये हमारा मेन एक्सप्रेशन होगा जिसको हम एक्सप्लॉइट करेंगे. k runs from 1 to n z by z minus bk minus summation k runs from 1 to n z by z minus bk. Okay, let's call this some star. Okay, now we go on to prove. तो पहले में हमारी कंडीशन क्या है फर्स्ट पार्ट में? फर्स्ट पार्ट में ये है कि सारे जो जीरोस हैं वो लाई करते हैं इन द रीजन z ग्रेटर देन इक्वल टू 1. यानी फर्स्ट पार्ट के लिए हमारी एजम्पशन है ये जो b केस हैं जीरोस. सो सपोज जो हमारा फर्स्ट पार्ट है which says that b के जो हैं they are bigger than equal to 1 for all k running from 1 to m. So then for z belonging to t यानी having the modulus 1 and z not equal to bk, we should have क्या होना चाहिए? Let me write it as this thing, modulus of z divided by z minus bk should be the same thing as modulus of 1 by z minus bk should be less than or equal to bk divided by z minus bk because bk is bigger than or equal to 1, which can be written as z minus bk minus 1. Of course ये यहाँ ले जाएंगे तो right. So I get modulus of something is less than equal to modulus of same thing minus 1. So by lemma 1 it means that by lemma 1 hence by lemma 1 जो कि मैंने मतलब जो obvious था वैसे lemma 1 ये कहता है then real part of z by z minus bk is less than equal to 1 by 2. मतलब तुम कभी भी evaluate कर सकते हो for all k running from 1 to up to m, which implies that real part of z into r dash z divided by r of z, which is equal to real part of summation क्या था अपना k runs from 1 to m 1 by z minus bk minus summation k runs from 1 to n 1 by z minus ak. and we can just add them. So it would be summation k runs from 1 to n. You would have here 1 by 2. Chalo main likhta hu. Real part of 1 by z minus bk minus summation. Of course, real part ko yahan le jate hain. Real part doesn't matter because real part of the sum is sum of the real parts, right? Now this is 1 by 2, right? So this is equal to, this is less than equal to summation k runs from 1 to n 1 by 2 minus whatever real part of summation k runs from 1 to n 1 by z minus ek, which is further less than equal to, actually strictly less than, है ना? अगर m depending upon m अगर n के बराबर हो, k runs from 1 to n 1 by 2 minus real part of summation k runs from 1 to n 1 by z minus ek, क्योंकि m is less than equal to n, तो अगर मैं एक 1 by 2 मैं कुछ 1 by 2 इसको ऐड कर रहा हूँ या कोई नहीं, in case they are same. Now this can be written as summation k runs from 1 to n, रियल पार्ट में बाहर निकाल सकता हूँ 1 by 2 minus 1 by z minus ek, सारे का रियल पार्ट, जिसको मैं लिख सकता हूँ, चलो ऐसे summation k runs from 1 to n, ये यहाँ 1 by 2 है, तो इसको अगर हम b z क्या मिलेगा मुझे minus ek minus 2 divided by twice z minus ek, तो ये हम अपने पास रखते हैं, राइट? ओके, so twice, ठीक है, ये z minus ek minus 2 फाइन, मैं इनको इकट्ठे लाया, एक हमें देखना है अभी, so I can write them as, what do I have? I've got z minus ek minus 2z, z, हाँ यहाँ 2, just a minute, कुछ गड़बड़ हो गई, 2 है, what do I get? I will get 2 here, z minus ek here, हाँ मैं भूल गया यहाँ पे z था, सॉरी, यहाँ पे z है, यहाँ पे z है, ऑफ कोर्स कुछ फर्क नहीं, सिर्फ मैं z लिखना भूल गया, तो यहाँ पे z था थ्रूआउट, यहाँ पे z था थ्रूआउट, so it would be minus twice z. Of course real part है यहाँ, real part of this whole thing, so that is the same as summation k runs from 1 to n, real part of this is minus 2z, so it should be minus ek minus z divided by 2 divided by z minus ek. Okay, so this is what I have. अब हम इसका real part निकालेंगे, so let's call it double star and evaluate this. So I have got minus ak plus z divided by twice z minus ak. पहले मैं इसको थोड़ा simplify करता हूँ, standard formula, तो I write it as minus ak plus z into z minus ak bar whole divided by twice z minus ak into z minus ak bar. And as you can see, this is minus ak plus z into z bar minus ak bar whole divided by twice mod of z minus ak का square, and then you multiply. So क्या मिलेगा हमें? Let's see, minus बाहर ही रखते हैं. It would be ak z bar minus ak into ak bar, then plus z into z bar, then minus z into ak bar, whole divided by 2 into modulus of. Okay, so this can be further simplified as minus को अंदर ले जाते हैं, a into a के bar is modulus of a के bar square, then plus z into a के bar minus a के into z bar minus a, Then I have minus modulus of z square whole divided by I should have twice z minus ak in modulus whole square. Now you can write that as modulus of ak square minus 1, assuming that now for mod z equal to 1 plus zak bar, as you can see, minus zak bar का whole bar, क्योंकि जब whole bar आएगा तो ये बन जाएगा a के z. So it's actually a complex number. We subtract its conjugate, right? हम इसको थोड़ा simplified form में लाना चाहते हैं, फिर हम इसका real part. So that would be ak square minus 1 plus twice iota into imaginary part of zak bar whole divided by twice z minus ak bar square. इससे क्या हुआ, इसका रियल पार्ट अलग होगा, क्योंकि आयोटा जिसके साथ होगा वो तो इमेजिनरी पार्ट है, मुझे इसका रियल पार्ट ढूंढना है. तो therefore real part of minus ak minus z divided by twice z minus ak is equal to modulus of ak square minus 1 divided by twice z minus ak modulus में whole square. Therefore substituting in second star, क्योंकि वहां पे हमें इसी में तो करना था, है ना, यहाँ पे हम सब्स्टिट्यूट करेंगे इसका रियल पार्ट क्या था. सो वी गेट, क्या मिलेगा हमें, we will get real part of z into r times z divided by r of z is less than equal to summation k runs from 1 to n modulus of a k square minus 1 divided by twice modulus of z minus a k square. मतलब ये यही है, हमने इसको सब्स्टिट्यूट किया. Real part of this is this, we just substitute it. Okay, but we know that ये हमने किया था पहले थ्योरम के लेवल में, that modulus of beta z is exactly equal to z into beta z by z, जो कि बराबर है summation k runs from 1 to n ak square minus 1 divided by mod of z minus ak square for mod z equal to 1. यहाँ पर भी है ये, we have assumed that mod of z is equal to 1. So therefore इसको यहाँ सब्स्टिट्यूट करो, सिर्फ 1/2 बाहर आएगा, बाकी तो सम वही है. So therefore जो हमें चाहिए था real part of z into r dash z divided by r of z is less than equal to 1/2 into modulus of b dash z. Of course, for mod z equal to 1 and rz not equal to 0. Okay. सेकंड में ये था, कुछ नहीं था, सिर्फ ये था जो जीरोस है ना वो इनसाइड, जो एक्स्ट्रा कंडीशन थी. सेकंड पार्ट अगर मैं देखूं, ये था, ये तो पार्ट फर्स्ट है. सेकंड पार्ट जो था इसका, I am assuming that it has got these poles which are and all zeros lie inside mod z less than equal to, यानी यहाँ पे था zeros lie outside, in outside unit this, यहाँ inside. तो सेकंड पार्ट में हमारी कंडीशन होगी, सेकंड पार्ट में, now if bk is less than equal to 1 for all k running from 1 to up to m and z belongs to t and z is not equal to bk. ये जरा एक मिनट, okay, दरवाजा बंद किया मैंने. So z not equal to bk, I should have a real part of z by z minus bk should be greater than equal to 1/2. बाय द सेम रीजनिंग जो अभी हमने किया ना, बाय लेमा 1। तो जिस तरह से हमने वहां किया था ग्रेटर देन इक्वल टू 1/2, मतलब बिल्कुल वही रीजन है यहाँ पर। वो तुम खुद कर लोगे आई थिंक। फॉर k रनिंग फ्रॉम 1 to up to n। सो 10 हमारा जो मिलेगा, मतलब कुछ नहीं करना, just substitute it in our star 1 divided by r of z, okay, is greater than equal to summation k runs from 1 to m 1/2 minus summation k runs from 1 to n real part of z divided by z minus ek, which is equal to real part of summation k runs from 1 to m 1 to m 1/2 minus z divided by, अच्छा यहाँ पर मैं n लेता हूँ, फिर मैं वो सब्ट्रैक्ट करूँ। अभी तुम देखोगे मैं क्या कर रहा हूँ, z माइनस ए सब पे कुछ खास नहीं, माइनस चूंकि मैंने m n से कम हो सकता है, तो यहाँ जो मैंने एक्स्ट्रा 1/2 ऐड करे वो मैं सब्ट्रैक्ट करूंगा, यानी k runs from m plus 1 to n जो होगा यहाँ पे 1/2 बाहर। Very easy, and this I already have shown in the first part। ये किसके बराबर है, मतलब करने की जरूरत नहीं है। दिस इज एक्चुअली इक्वल टू रियल पार्ट ऑफ, क्या मुझे मिलेगा, समेशन के रन्स फ्रॉम 1 to n, क्या किया था मैंने वहां पे, माइनस z माइनस ए के, मतलब कैलकुलेशन करके डिवाइड बाय 2 into z minus a k, but I have another term summation k runs from 1 to m plus 1 to n 1/2, and of course this was equal to summation k runs from 1 to n mod of a k square minus 1 divided by 2 into z minus a k square, then this is of course 1/2 kitne bar, of course n minus m times, itne 1/2 hai. And this we already know is modulus of b dash z 1/2 minus 1/2 n minus m, and that proves the lemma second. That proves the lemma second. लेकिन I don't know, was it greater than equal to or less than equal to? Just a minute, मैं जरा चेक करना चाहूँगा, नहीं ठीक है, हाँ, did I make a mistake? हाँ, greater than equal to here, so उसमें था less than equal to जो पहले वाले में था, इसमें greater than equal to है because by the same reasoning, क्योंकि अब b के जो होगा वो less than equal to 1 होगा, इसमें भी greater than equal to 2 जो हमने पहले वाले में हिस्से में किया था उसको यहाँ repeat करो तो no issue. So that finishes lemma second. So now let's come to the proof of the theorem. Proof of the theorem में ज़्यादा कुछ करना नहीं basically. Proof of the theorem. Now we have to show that, just to repeat the statement, if all the zeros of R lie in mod z less than mod z greater than equal to 1, then हमें ये चाहिए 1/2 into b dash z into norm of R. Now this is what we have to prove, of course, for mod z equal to 1. But we already know from previous theorem that R star z का derivative plus R dash z का derivative is less than equal to b dash z into norm of R for mod z equal to 1. So it suffices to show that, अगर हम ये दिखा दें तो this should be sufficient. What? if I show that r star z का जो डेरिवेटिव है वो है बिगर देन इक्वल टू r dash z, तो फिर क्या होगा, you would have twice r dash z would be less than equal to this thing, so r dash z would be less than equal to 1/2. So अगर हमने ये प्रूव किया तो it should be sufficient. Okay, also we know that हाँ अगर हमने ये दिखा दिया for more z also z into b dash z by b of z, we know that this is actually equal to mod of b dash z, हम प्रूव कर चुके हैं, which is strictly positive in our case because it is that sum जो हमें मिला था. Now what? Also ये हमें करना चाहिए लेकिन हम प्रूव कर चुके हैं एक जगह. So repeat that from previous theorem. Previous theorem में हमने प्रूव किया था this derivative is equal to z into b dash z b of z into r of z minus z into r dash z. ये हम प्रूव कर चुके हैं. मतलब you will copy it from that theorem. मतलब reproduce it from previous theorem जब हमने वो evaluate किया था इसका derivative. So which is the same thing as, अगर मैं इसको लिखूं ऐसे z r dash z divided by, should I write it like this, यहाँ पे टाइम ये खत्म होगा लेकिन हम फिर से ज्वाइन करेंगे. लेकिन आमिर या उमर तुम ये अटेंडेंस का देख लेना, तुम मुझे सुन रहे हो कि सो रहे हो? हेलो आमिर उमर दोनों में से जो भी है वो अटेंडेंस देख लेना. हेलो हेलो हेलो
ओके सर.
मेरी आवाज आ रही है कि मुझे लगता है तुम सो रहे हो?
यस सर.
यस
Okay.
सर.
ये इसके बराबर है, यहाँ तो वो आर्गुमेंट रिप्रोड्यूस करोगे जो थ्योरम 1 में हमने किया था, हमने ये डेरिवेटिव इवैल्यूएट किया था, ये इसके बराबर होता है. इट मींस दैट z into r dash z divided by b dash z into r of z जो -1 into modulus of b dash z और into modulus of r of z, ये मैंने बाहर निकाला. Let's call this equation 1. मैंने ये बाहर निकाला, मतलब दिस इज व्हाट यू गेट. यहाँ डिवीजन में आ जाएगा और वहां से बाहर चला जाएगा. b dash z ये वाला कंपोनेंट मैंने बाहर निकाला in modulus. So real, now we know that real part. Now from lemma 2 अगर सारे zeros बाहर हैं, then I know that real part of z into r dash z by r of z is less than equal to 1/2 into modulus of b dash z. So that is, I can write it